Greetings everyone. We would like to welcome you all in this amazing video tutorial where we will explore the diverse approaches for installing Symcloud Storage. Without any further delay, let's dive right in and get started. Let's have a look at the agenda. In this tutorial, we will understand about Symcloud Storage, its prerequisites and install options. Then we will understand pre-installation checks, followed by live demonstration for installing Symcloud Storage on native Kubernetes. Symcloud Storage is an enterprise-grade advanced storage and data management solution that was previously known as Robin Cloud Native Storage or Robin CNS. It can be deployed as a standard Kubernetes operator and manage stateful workloads with ease. Symcloud Storage is compatible with a wide array of orchestration platforms which includes Red Hat OpenShift, Google Anthos, and managed Kubernetes like GKE, AKS, EKS. You can also install it on native Kubernetes as well. When considering the prerequisites for Symcloud Storage installation, specific requirements must be met. In terms of resources, a minimum of 4 core CPUs and 4 GB of RAM is essential for any node. The supported Kubernetes versions as of today are from 1.16 to 1.27 version. Additionally, Symcloud Storage mandates a minimum supported kernel version and requires target core user and TCM loop kernel modules to be loaded. The designated port range, which must be open for Robin services, spans from 29442 to 29470. Furthermore, Symcloud Storage extends its compatibility to various operating systems like CentOS, Container Optimized Operating System, Red Hat Linux, Edge Operating System, Ubuntu, and CoreOS. Don't worry for now, we will thoroughly cover these prerequisites by referring official documentation during our demonstration. When we talk about the installation options, Symcloud Storage provides two methods for deploying Symcloud Storage. The first option is by using robin.yaml file, which contains comprehensive information for the installation components. The second method is by using Robin installer command. In this tutorial, we will be leveraging the Robin installer to set up Symcloud Storage from scratch. After ensuring that all the prerequisites are met and installation option is selected, the next step is to perform quick pre-installation checks. This is accomplished by executing install-robin.sh with an option --execute-prechecks. It's important to mention that you can obtain the installer files either from get.robin.io or by reaching out to the Robin support team. In this demonstration, we will go through the official documentation, perform the pre-checks followed by installation and dashboard access. So let's begin by exploring the documentation first. Go to docs.robin.io. Select the version of your choice and click on Read Docs under Cloud Native Storage section. At the time of recording, the latest CNS version is 5.4.6 and we will now explore the documentation for it. Click on Robin Cloud Native Storage Overview, which will provide a high-level understanding of industry's leading storage and data management solution for Kubernetes. As we can see, Symcloud Storage or CNS is compatible with Red Hat OpenShift, managed Kubernetes like GKE, AKS, and EKS, Google Anthos, and with native Kubernetes. In order to check the prerequisites and installation options, click on Installing Robin Cloud Native Storage, which is on the left side. Under Prerequisites section, you will find information on resource requirements, which is minimum of 4 core CPUs and 4 GB memory per node. Supported Kubernetes versions, supported operating systems, minimum kernel version, required kernel modules, which are target_core_user and TCM_loop. If you further scroll down, you will find the port requirements ranging from 29442 to 29470 for Robin services. There are few more requirements if you are considering CNS for your production ecosystem. As mentioned earlier, CNS can be installed in two different ways. One by creating and using robin.yaml file, and second by Robin installer command, which is install-robin.sh. Now that we are familiar with the prerequisites, let's proceed with the setup. In our case, we will be setting up CNS on native Kubernetes, and hence we would be having Kubernetes cluster in place. In our case, we have 2-node Kubernetes cluster, which is up and running. The nodes are all in ready state. We should have the CNS binaries with us. In order to obtain CNS binaries, go to get.robin.io. Click on sign in, provide your email address, and you will receive a link on your email like this. Paste this link on your browser. You can see all details on this page. Now click on downloads and select the software of your preferred Kubernetes platform. We can observe the CNS software is of old version here. And hence, in this case, if you wish to get the latest version, you should contact Symcloud Storage or Robin support team. In our case, we have received the binaries from their support team, which we will show you in a while. Let's verify the prerequisites of our cluster first. We have 8 GB RAM and 4-core CPUs on our master node. Even the worker is also of the same configuration as shown here. The operating system is the supported one, which is CentOS 7. The kernel version is greater than the supported one as mentioned in the documentation. Next, we will need to ensure the required kernel modules are loaded. So copy and paste lsmod command from here to check the module status. Both target_core_user and tcm_loop kernel modules are absent. Let's find both of these modules by running this command. We have target_core_user module here, and similarly we will find tcm_loop like this. Let's load both of these modules using modeprop command. And here we can see both target_core_user and tcm_loop modules are loaded. We have to load both of these modules in the worker node as well. In this demo, we have opened all the ports. Let's confirm it by verifying the security group associated with our VMs. We got the latest binaries from CNS version 5.4.6 from Symcloud Storage team. Go inside CNS binaries directory and you will see all installer and many YAML files here. We will be using Robin installer utility, which is install-robin.sh. This will going to help us to do pre-check for our installation. In order to do the pre-checks, let's execute /install-robin.sh space --execute-prechecks. Let us open another session and observe that the installer will create a namespace named Robin-precheck and create few pods and jobs which will verify and check the prerequisites. Once the prechecks are completed, we can examine the check file which will provide us the details of the checks for every node. In our case, everything looks fine for both of our master and worker node. We are good to proceed with CNS installation now. Let's run /install-robin.sh. Confirm the prechecks by typing yes. This will start the installation by creating multiple resources including namespaces, deployments, daemon sets, jobs, secrets, config maps, custom resources, and storage classes, etc. The entire process will take approximately 10 to 15 minutes to get completed. So finally, our installation is completed now. Let's switch to the other session and observe the deployed resources. You will see a namespace named Robin.io. This is a namespace where most of the Symcloud storage objects has been deployed. Let's run kubectl get all-n robin.io. This will going to show you all the major objects deployed by Symcloud Storage. We can see Robin master pod, which is deployed as a deployment. The Robin master pod acts as a manager. It runs the major master services like Robin server, Robin event server, Robin authentication server, Sherlock, node monitor, PGSQL, and HTTP server. Robin IO Manager or IOMGR. Robin IOMGR pods are deployed as a daemon sets, and they are responsible for handling IO requests from the application. In the latest CNS releases, Patroni has been introduced as an independent PostgreSQL cluster. This is deployed as a part of Robin CNS installation as a stateful set. Robin worker pods are deployed as daemon sets as well. This will run the agent services like monitoring. Few more pods are also created for the purpose of storage attachment, provisioning, resizing, snapshots, etc. Finally, our installation is completed. Let's verify the same by checking Robin clusters CRD. We can see a CRD with a name robinclusters.manage.robin.io. Let's describe this CRD using kubectl describe command. And you will observe a status indicating online and ready for nodes. In our case, we have two nodes and both are in online and ready state. Let's log in into the Robin master pod by executing kubectl exec-it master pod name -n robin.io --bash. From here, we can log in into the Robin cluster to verify the cluster status. You can check the default username and password, which is admin and robin123 in our case. Running Robin host list will show user is not logged in. Let's log in by running robin login admin -- password, which is robin123. Now verify the Robin cluster status using Robin host list. Both of our nodes are showing ready and online. By running kubectl get sc, we can verify the default storage classes which gets deployed by CNS. You need not to activate anything here. Run Robin license info command, which will show you the evaluation license which is active for 89 days. You can access Robin UI on port 29443. Everything is internal as we can see cluster IP with all services. In order to access CNS dashboard, we need to change Robin-master services from cluster IP to node port or load balancer. Let us change it to node port in our case by running kubectl edit and change the cluster IP to node port. You can see the service type is node port now. And 29443 is mapped with 30532. Let's try to access the dashboard on port 30532. Check the public IP of your node and paste it in the browser with port 30532. Enter the username and password to access Robin UI. You can see there are no active alerts, and under nodes section there are two online nodes. That's it for this demo, and we will learn and explore more about the UI in our upcoming tutorials. With this, we have come to the end of this video. If you enjoyed the video, please consider liking and subscribing to our channel. To learn more about our organization, feel free to click on the link provided in the description box. We shall see you in our next video. Thank you for watching and stay tuned for more updates from us.